Now, after we defined the unit step function, we want to find its Laplace transform. So, take a Laplace transform of step function. By definition of Laplace transform, that equals integral from 0 to infinity e to a negative st function dt. Because function equals to 0 before a, we switch to integral from a to infinity e to the negative st and multiply it by 1. That's the value function when t is bigger than 1. We find antiderivative e to a negative st over negative s from a to infinity, and we're going to get e to a negative s times infinity over negative s minus e to a negative sa over negative s. First one equals to 0 under assumption when s bigger than 0. So we're going to get e to a negative sa over s under assumption when s bigger than 0. So Laplace transform of u of t minus a equals e to a negative sa over s, and the domain of a function is when s bigger than 0. So we define a Laplace transform of a function. The same way we can define a Laplace inverse. So Laplace inverse of e to a negative sa over s is going to be equal to step function of u of t minus a. Now let's write an example. If I want to find Laplace of window function between a and b, that is step function of t minus a minus step function of t minus b, and I want to take Laplace transform that expression. Laplace transform of u of t minus a is e to the negative sa over s. Laplace of step function t minus b is e to the negative sb over s. Maybe factor 1 over s out, and we're going to get e to a negative sa minus e to a negative sb. And that will be Laplace of window function between a and b. If I want to calculate Laplace transform of f of t minus a times u of t minus a, by definition of Laplace transform, that equals integral 0 to infinity e to a negative st f of t minus a step function t minus a dt. By definition of step function, it equals to 0 before a, so before a integral equals to 0, e to a negative st f of t minus a, and when t is bigger than a, our step function, because it's unit step function, equals to 1. Now we'll do substitution. We'll do substitution tau equals to t minus a, then d tau equals to dt, because t is changing from a to infinity, tau which equals to t minus a is going to be changing from 0 to infinity, and also because tau equals to t minus a, you also notice that t equals to tau plus a. So we'll proceed with that substitution. So we're going to get integral. Now tau is from 0 to infinity, tau from 0 to infinity, e to a negative s, tau becomes, t becomes tau plus a, f of tau because tau equals t minus a, and dt equals to d tau. dt equals to d tau. So we're going to get integral 0 to infinity e to negative s tau minus sa f of tau d tau. I rewrite that integral as e to the negative s tau e to the negative sa f tau d tau. So what we notice is that e to the negative sa is a constant with respect to tau, so we can push it outside of integral. And we have integral from 0 to infinity e to the negative s tau f tau d tau. And if you look at the integral which is written right here, what you notice is that is the same as integral 0 to infinity e to the negative s t f t dt, which is Laplace transform of function f. So what we notice is at the end we get e to the negative s a times Laplace transform of f. So what we end up with, Laplace transform of f of t minus a times u of t minus a equals e to the negative sa Laplace of f. Now we will rewrite the last formula as a theorem, and we'll state it something like this. Theorem translation in t. So if we start function capital F of s, which is Laplace transform of f, and let that capital F of s exist for some s bigger than alpha. Now if a bigger than 0, then Laplace of f of t minus a times step function u of t minus a equals e to the negative as Laplace of f. And correspondingly we can write down the Laplace inverse of e to the negative as f capital F of s equals Laplace inverse of e to the negative as Laplace of f equals f of t minus a u of t minus a. So that's theorem translation in t. It's a bit more convenient to use this formula in the following way. So instead of starting with the left side Laplace transform of f of t minus a and u of t minus a, we start with Laplace of g of t times step function. So what we do, we essentially will do substitution, and we do substitution, and we're going to call tau equals to t minus a, and we introduce a slightly different function instead of g, like h, but we're essentially going to get the same answer as we got here. The only difference is instead of having argument t, we're going to get the argument tau, which is t plus 1. So we're going to get e to the negative as Laplace of g of t plus a. So that is more convenient way of using the theorem translation in t. Let's an example or two. Let's run an example or two how we're going to be using it. So if I take Laplace of t times u of t minus 3. What you notice in our case that g of t equals to t, a equals to 3, and g of t plus 3 equals to t plus 3. So what you're going to get is, if you use the previous formula, e to the negative as, e to the negative 3s times Laplace of g of t plus a, g of t plus 3, which is t plus 3. And we're going to get e to the negative 3s. Laplace of t is 1 over s squared. Laplace of 3 is 3 over s plus in between. And that's the answer for Laplace transform of t times u times t minus 3. So to use this formula, we need to figure out what g of t is, we need to figure out what g of t plus a, and then take Laplace of that. Alright, so let's maybe quickly write down one more example. Find Laplace of t squared times step function t minus 2. So we want to use the formula. To use that formula, we need to figure out what function g of t is, we need to figure out what a is, and we need to figure out what is g of t plus a. Alright, so 3 things. What a is, what g is, what g of t plus a is. So in our case, g of t is function, which is in our case t squared. A is going to be 2. G of t plus a is going to be g of t plus 2. So it's going to be t plus 2 squared. Square that expression, we're going to get t squared plus 4t plus 4. So we're going to get Laplace of t squared u of t minus 2 is going to be equal to e to the negative 2s. Laplace of g of t plus a, which is t squared plus 4t plus 4, so e to the negative 2s. Laplace transform of t squared is 2 over s cubed. Laplace transform of 4t is 4 over s squared. Laplace transform of 4 over s. And that's going to be final answer for this problem.